Number 12 says find the rate of change of this function when x equals 2. So rate of change means slope. They gave us 1 point, so finding the slope at 1 point comes from the derivative. So the first thing I'm going to do is rewrite this function. I have 1 over the 4th root of x minus 1. That's the same as x minus 1 to the negative 1/4. That's my function. So now we'll take the derivative. The negative 1/4 comes down in front, and I subtract 1 from the exponent. Negative 1/4 minus 1 is negative 5/4. That's the derivative. They want the slope at this point, so we're going to go plug the 2 in for x. We can say m equals negative 1/4 times 2 minus 1 to the negative 5/4. And again, that's our answer. That's a number. We can leave it alone, or we can clean that up. I'll clean the inside up first. That's a 1. 1 raised to any power is still 1. So I'm left with negative 1/4 times 1. Let's take a look at 13. 13 says, here's a function. Find the equation of the normal line through the point negative 1, 3. Remember, a normal line is perpendicular to the tangent line, and the slope of the tangent line comes from the derivative. So, we want to write the equation of any line. We need a point, and we need a slope. Now, the good news is they gave us the entire point. The slope will come from the derivative. Be careful, I'm going to jot this down. We want the slope of the normal line, but the derivative will give us the slope of the tangent line. That's all right. So we'll say y prime equals, I'm going to take the derivative. I get 6x squared minus 4. I would like the slope when x equals negative 1. So I'm going to go plug in my negative 1, and I get 2. This is the slope of the tangent line, right? The derivative gives us the slope of the tangent. We want to be perpendicular to the tangent, and so our slope will be the opposite reciprocal. So now we can write the equation of our line in point-slope form. Good. Number 14, a little more, it's actually a combination of 12 and 13. Find the equation of the tangent line. So just like before, we need a point and we'll need a slope to this curve when x equals negative 3. So we're going to go find the point. Here's our way to find y. I'm going to go plug a negative 3 in. Negative 3 plus 1 is negative 2. I do not, off the top of my head, know the cube root of negative 2. It's decimal. Okay. But now we want to find the slope. Slope comes from the derivative. The first thing, just like on number 12, we're going to need to rewrite this as a power. And now we can take the derivative, bring that 1/3 down in front, subtract 1 from the exponent. This is not the slope, this is a formula for the slope. We need to plug in our x. So we can say the slope of the tangent equals 1/3 times negative 3 plus 1 to the negative 2/3, or 1/3 times negative 2 to the negative 2/3. That's the slope of my tangent. Now, I'm not saying we can't clean this up at all. I'm just going to leave it alone. So now we're going to use point slope form. Y minus the cube root of negative 2 equals my slope times x plus 3. Now I don't technically need it here because it is all multiplication, but I'm going to go ahead and put parentheses around my slope just because we want to make sure that entire thing gets multiplied by x plus 3.